Here, this is the geometry foundation video. Starting with question 1. The topic here is a multi-step angles in parallel lines problem. So you can help with your revision. Let's look at the question. So, a parallelogram. This is basically describing what we can question to the various different points. And you've got the indicator A, B, C parallel, B, A, and the B are parallel. We need to work at angle C. Give a reason for each stage you work. Knowing where is that angle, the letter in the middle, in the 3 letters, is where the angle meets. And the other 2, so B, C, D, joins up those 2 lines at that angle. So we need to work at this angle here. Now I like to think of these problems a bit like solving a puzzle. Can we fill in the pieces to help me find a particular angle? Straight away, if I need an angle here, then I've got it in a triangle and I can, but I can't find an angle unless one out here. Okay? So how are we going to go about solving this? Well, let's think about what we know. We know that this angle here is 70 degrees, and we can see actually, if you look up here now to this angle here, which will be DAB, I'm looking at that and I can see that those angles there and there, they're forming that Z shape, so this must be an alternate angle to the 70 degrees. Okay, so that's going to be my first stage of working. How do I write that? Well, as it says, reason for each angle you work out. So first of all, let's get the actors to describe it. It will be angle DAB, because it goes DA to B, equals 70 degrees. And what is my reason? Alternate angles are equal. I picked up a mark for my angle and a mark for my reason. Okay. Now, looking at this, I'm also told that AD and BD are equal. That shows lines. So that means that this must be an isosceles triangle, because I've been told that those 2 sides are the same. If this is isosceles, then this angle must equal 70 as well, because the base angles in an isosceles triangle are equal. So let's write down that angle there. It meets at B, it goes from A, B to D. So I'm going to write that down. Angle A, B, D equals 70. Reason, base angles in an isosceles triangle. Okay, right, I found 70, I found 70. I can find this angle now. This is going to be 40 degrees, or you could actually see that these 2 are alternate as well, so that would give me that angle. But let's do it this way. This angle is 40 degrees, and what angle is that? That's ADB. So angle ADB equals 40 degrees. Reason for that: angles in a triangle add to 180 degrees. Okay. Next step, I can now work out BDC, straight line, so I know that is going to be 70 as well. Okay, so write that down. Angle BDC equals 70 degrees. Those 2 alternate, but use the fact that it's on a straight line. So angles on a straight line add to 180. Now I've done everything that I need to then work out this final angle here. angle BCD, that's going to equal 100 degrees because angles in a triangle add up to 180. So equals 100 degrees, and my reason, angles in a triangle add to 180 degrees. Okay, so that'll be my final answer there. Look at how I'm setting out the final answer now. You're stating the angles using the correct letters to describe where it is on the diagram, and each time you're writing your reason as to how you know that angle is correct. That's what you need to do to get full marks in these sort of questions. Okay, let's move on to question 2. Okay, so we've got showing a path in a park. But let's focus on what the actual maths is here. We've got a square of side 40 meters, so straight away I know that all of these sides are the same. Okay, E is the midpoint of AB. So again, if I know this is going to be 40, then I know that these lengths here will be 20 because it's the midpoint, and that will be the same here. Okay, the circular path is in the center of the square and has a radius of 5 centimeters. So remember that radius is the distance from the center to the edge, so that's a radius of 5. It says work out the percentage of the square that is shaded. So let's think what I've actually got here. I've got my full square. I've essentially got half of the square, which is this rectangle, and then a section of that rectangle has been cut out by what is essentially half of this circle, or a semicircle. Okay, so I need to work out how much of the square is shaded, and I'm going to do that by finding the area of the full square, area of the rectangle, and the area of this semicircle here. Let's start with the square, and that's going to be simply 40 squared. Okay, so 40 times 40 would be 1,600 meters squared. Okay, now let's do the area of the rectangle. Okay, very simple again, 20 times 40, so that's going to be 800 meters squared, just simply half the area there. Okay, let's find the area of the semicircle. And reminder of the area of a circle, area equals pi r squared. Okay, so to find the area of the semicircle, it's going to be half of that. So we're given the radius, so it's going to be pi times 5 squared divided by 2. Okay, now I'm going to actually just leave that in the format of pi initially by doing 25, 5 times 5, pi over 2, which is 12.5 pi. The reason why I do that, I'm going to subtract that from the rectangle in a moment, and it's easy just to write the answer in pi. Okay, so what's the actual area of the shaded section? Well, what we actually got to work out there, we've got the rectangle is 800 minus the semicircle, which is 12.5 pi. Okay, so I'm going to now use my calculator to do that. Okay, so that is 760.73. I'll do it to 2 decimal places. Okay, so that is meters squared to 2 dp. Right, the final thing is to work out the percentage. So what is this 760 out of the 1,600 as a percentage? So to work out the percentage, first create a fraction of what you have, the 760.73 and so on. Divide that by the total area, okay, with the 1600, and then we're going to times that by 100. I'm just going to use my answer that I've still got on the calculator, divide that by 1600, okay, and then times that by 100. That turns it from a decimal to a percentage, and you can see it's going to be 47.54. Okay, so I'm going to put that to one decimal place, 47.5. Okay, a lot to go through there, but look at how I've set up my method, step by step, line by line, structuring my method, and then getting to my answer. Okay, final question in this video. Okay, let's have a look at what we've got here. So we've got a triangle ABC. D is on the line AB. We're told the length here, and we've got an angle. My immediate thought with this sort of question, I'm checking as well what I have to do. I have to get the length of AC to the ratio of DB. So if I'm talking about length here, and I've got right angles and I've got side lengths and angles, I'm thinking it's going to involve either Pythagoras or trigonometry, or a combination of the two. So I'll start with Pythagoras. Just a reminder of the formula: a squared plus b squared equals c squared. And reminder of trigonometry, it's SOHCAHTOA. And I've set it up like that so I know how to use those in the same way you use formula triangles. Let's see if we're going to use that to help work out this question. So what length do I need to find? I need to find AC. I don't know what this length is here, so I use X to represent that. Okay. Now I could use trigonometry straight away, but I've only got an angle here. I don't have this length here, and I don't have this length here. So if I had this length here, if I was able to work out C to D, okay, then I could use that to help me find A to C. So let's find D to C first. And how can I do that? Well, it's Pythagoras' theorem. I've got C, I've got A, I need B, so I'm going to do the inverse of this. I'm going to subtract the squares of those. So, remember Pythagoras' theorem, you do the square root of, in this case, it will be C squared minus A squared. So it's going to be 10 squared minus 6 squared. So that's going to equal 100 minus 36. Square root, therefore, of 64, which equals 8. I know the square root of 64 is 8. So this length here is 8. Okay. Pointing out now that this is actually a non-calculated question. And you're probably thinking, hold on, trigonometry, it's always going to be a calculated question. Well, this came up on a non-calculator, and that's because the trigonomic ratio that we're going to use to find length AC is one of those that you need to memorize and know. Okay, let me explain why. With this now, I'm going to apply the length that I have and the length that I need in the same way that I do with any trigonometry question. So the 8 that I've worked out is opposite the 30, so I'll label that opposite. AC is going to be the hypotenuse, so I know that I will use the sine ratio to work out what H is. Using the formula triangles as well, I can see I'm going to do opposite over the sine of the angle. Okay, so let's just write that out. So we've got that. That's the rule that you learn. So I want H, I want the hypotenuse. So in this case, I'm going to do the opposite, which I know is 8 over sine of the angle sine 30. Okay, but how do I work out sine 30? Well, this is one of the key ratios that you need to memorize, and let me show you how to do that very briefly. Okay, let's take a equilateral triangle for a moment. Okay, and let's give that equilateral triangle side lengths 2. Okay. Now if I split that in half, first of all the angles are going to be 60 in all of them, but if I split that in half and worked out this angle here, that will be 30. Let me draw that again. I'm just going to turn it round slightly, so I've now got the 30 here and the 60 here. Okay, I've just rotated that round slightly. This length here is going to be 2. This length with the 60 is going to be 1. Okay, and what is sine 30 going to equal? Well, you can see that this now is opposite the angle, and this is the hypotenuse. So to use the sine rule, the sine ratio, sine 30 equals opposite, which is 1, over hypotenuse, which is 2. So I've shown there that sine 30 is actually a half. Okay, sine 30 is a half. Now it's going back to the length that we're working out. I've now worked out that sine 30 is actually a half, or I could write it as 0.5, and I'm going to use that in my question now to work out the hypotenuse. I need to obviously times this by 2 to make that 16 over 1, so the length of the hypotenuse is going to equal 16. Okay, so based on that I've worked out that AC equals 16. Okay, so this length here is 16. Final step then is to write it in the ratio. So the ratio A to C is 16, D to B is 6, and it says in its simplest form, so I'm going to cancel this down to become 8 to 3. And there you have it. 5-mark question that applied both Pythagoras and trigonometry, and it applied a trigonomic ratio, an exact trig value that you need to know. Sine 30 is a half, and we had to simplify a ratio. Lots going on there, but I hope this video has been helpful.